Black holes are one of those things everyone pretends to understand until someone starts saying words like event horizon, singularity, spacetime, quantum radiation, and suddenly your brain starts looking for the nearest exit. So today, we are going to explain black holes without making your brain hurt, or at least without hurting it more than the universe already does on a daily basis. First of all, a black hole is not actually a hole. I know, terrible branding. It is not a tunnel, not a portal, not a shortcut to another universe, and sadly, not a secret cosmic drive-through. A black hole is basically what happens when a ridiculous amount of matter gets crushed into a very tiny space, creating gravity so strong that once something gets too close, not even light can escape. And when light cannot escape, that is usually a pretty good sign that the situation has gotten out of hand. Most black holes form when a massive star reaches the end of its life. Stars spend most of their time fighting gravity by using nuclear fusion, which is basically the star constantly exploding in a controlled way so it does not collapse into itself, which honestly feels relatable. But eventually, a massive star runs out of fuel. Gravity wins the argument, the core collapses, and if enough mass is left behind, it becomes a black hole. So in a way, black holes are just dead stars that took retirement extremely personally. Now, black holes come in different sizes. There are stellar black holes, which are usually several times heavier than our sun. There are intermediate black holes, which are the awkward middle children that scientists are still trying to fully understand. And then there are supermassive black holes, which can be millions or even billions of times the mass of the sun, and usually sit at the center of galaxies like they own the place, because honestly, they kind of do. There is even one at the center of our Milky Way called Sagittarius A star, which means our galaxy basically has a giant invisible monster in the basement, and everyone is weirdly calm about it. But before you start panicking, black holes are not giant space vacuum cleaners. They do not just suck up everything in the universe like someone turned on a Dyson in space. If the sun magically turned into a black hole with the exact same mass, Earth would keep orbiting it like normal. We would not get sucked in. We would just freeze to death because the sun would no longer be giving us heat or light. So still very bad, just a different flavor of bad. The point where things become truly doomed is called the event horizon. This is the boundary around a black hole where escape becomes impossible. It is not a solid surface. You do not hit it like a wall. There's no sign that says, "Welcome to the point of no return. Please keep your arms and legs inside the ride." It is just the line where every possible path forward leads deeper into the black hole. Once you cross it, you're not coming back. Not because you made a bad decision, even though you definitely did, but because physics has removed all other options. Around some black holes, you might see something called an accretion disk, which is a glowing swirl of gas, dust, and unlucky material spiraling around the black hole before falling in. This disk can get insanely hot because everything is moving fast, crashing into itself, and generally having the worst traffic jam in the universe. So when you see those famous black hole images with a glowing ring around a dark center, you are not seeing the black hole itself. You are seeing the stuff around it getting cooked by gravity. The black hole is the dark part in the middle, sitting there silently like it just deleted your homework and refuses to explain itself. Some black holes can also shoot out massive jets of particles, which sounds confusing because we just said, nothing can escape a black hole. But the jets are not coming from inside the event horizon. They come from material and magnetic fields near the black hole before everything crosses the point of no return. So the black hole is not breaking the rules. The rest of the universe is just being extra dramatic nearby. Now let's talk about the singularity, because this is where science starts sweating. At the center of a black hole, according to general relativity, all the matter gets crushed down into an extremely tiny point with basically infinite density. And anytime science starts using the word infinite, you know someone is either very smart or very close to giving up. The singularity might be a real thing, or it might be a sign that our current math stops working and we need a better theory. So if someone tells you they fully understand what happens inside a black hole, they are either lying, joking, or trying to sell you a course. One of the most famous things that could happen near a black hole is called spaghettification, which is probably the greatest scientific term ever created. This happens because gravity pulls harder on the part of you closest to the black hole than the part farther away, stretching you out like a piece of cosmic spaghetti. So yes, if you fall into a black hole, there's a real chance your final form is pasta. Near a smaller black hole, this could happen before you even reach the event horizon. Near a supermassive black hole, the event horizon is so huge that you might cross it without immediately noticing anything crazy, which sounds comforting until you remember that you are still inside a black hole and the rest of your future has been canceled. Black holes also mess with time. From far away, someone watching you fall toward a black hole would see you slow down more and more as you approach the event horizon, like the universe started buffering. From your point of view, though, time would feel normal as you continued falling inward toward your extremely unpleasant appointment with gravity. This is what makes black holes so disturbing. They are not just big, scary objects. They are places where time, light, space, and common sense all start behaving like they were written by a committee of sleep-deprived physicists. And just when you think black holes are already weird enough, there is Hawking radiation. Stephen Hawking proposed that black holes may not last forever. Because of quantum effects near the event horizon, black holes could slowly leak tiny amounts of radiation and eventually evaporate. But do not imagine a black hole dramatically shrinking like a balloon losing air. For real astrophysical black holes, this process would take an absurdly long amount of time, like so long that your phone calendar would probably crash trying to schedule it. So how do we even know black holes exist if they are black and invisible? Easy. We catch them bullying everything around them. We watch stars orbit something we cannot see. We detect gas heating up as it spirals around them. We measure gravitational waves from black holes crashing into each other. And with the Event Horizon Telescope, scientists even captured images of the shadow regions around supermassive black holes, including the one in Galaxy M87 and the one at the center of our own Milky Way, which means we have looked at the neighborhood of an invisible cosmic monster and basically said, yep, something horrible lives there. So to recap without turning this into homework, a black hole is not a hole, not a vacuum cleaner, not a guaranteed wormhole, and not something you should visit for content. It is a region of space where gravity has become so extreme that beyond the event horizon, escape is impossible. The glowing stuff around it is usually the accretion disk. The center may contain a singularity. Falling in could turn you into spaghetti, and the whole thing might very slowly evaporate over a timescale so stupidly long, it makes human history look like a loading screen. And maybe that is what makes black holes so terrifying. They are not magic. They are not glitches. They are the universe working exactly the way physics says it should, just in a way our brains were clearly not built to handle.